Hello my dear students, most welcome to our channel SHUKLA Maths Academy, Jabalpur. Today in this video, we will discuss about the differentiation of parametric functions or equations. So now first I will explain what is a parametric equation. If any function is the function of other variable, then this is called a parametric equation. For example, x is equal to function of t, right? And also y is the function of t, and we have to find the value of dy by dx, right? So there is a formula to finding the differentiation or derivative of the parametric function such types. The formula is that the dy by dx is differentiating the y with respect to t and divided by differentiation of x with respect to t, right? So we get the required derivative of the given parametric functions. I will explain it by taking an example. Suppose we have the problem if x equal to a cos t and y equal to b sin t, then we have to find dy by dx, means derivative of these parametric equations. So now first we will apply the formula. The formula is that dy by dx is equal to dy by dt and divided by dx by dt. So clearly we can easily find the dy by dt by the given function y equal to b sin t, and its derivative will be b cos t. So it becomes b cos t divided by dx by dt. Our x is a cos t is given, and its derivative will be dx by dt, and it will be minus a sin t. So we know that it is minus b by a, and cos t by sin t is cot t. So the derivative of given parametric equations is minus b by a cot t. I will take some more examples based on the differentiation of parametric equation. Now our next problem is that if x equal to whole into a into cos t plus log 10 t by 2 and y equal to a sin t, then find the value of dy by dx, means derivative. So clearly here the function x and y are the function of t, means function of ft. So we must use here the formula differentiation for parametric equations, right? So first we will find the derivative of x with respect to t. So we get dx by dt. It becomes a is constant, derivative of cos t is minus sin t, plus derivative of log 10 t by 2 is derivative of for log is 1 upon 10 t by 2 into derivative of 10 t by 2 is sec square t by 2 into derivative of t is 1 by 2. And now on simplification this we get a into minus sin t as it is, and it is plus 1 upon 10 t by 2, that is cot t by 2, and sec square t by 2 we can write this 1 upon cos square t by 2, and this 2 also here, so write down here 2 into and bracket close. And after that it becomes a into minus sin t plus cot t by 2, we can write this as cos t by 2 upon sin t by 2, and into also here 2, and that is cos square t by 2. So cos t by 2 and 1 cos t by 2 will be cancelled, and now this becomes minus sin t as it is, and plus here 1 upon 2 sin t by 2 into cos t by 2, it becomes sin 2 into t by 2, means sin t. So we can write this as a upon LCM is sin t into minus into plus minus sin square t, and this is 1 here as it is, so it is 1 minus sin square t. So this becomes 1 minus sin square t is cos square t into a, so it is a cos square t divided by sin t. So this is the value of dx by dt. So our dx by dt becomes a cos square t by sin t, and also find the value of dy by dt. So our y is a sin t and its derivative becomes a cos t. And now using the formula for parametric equations for differentiation dy by dx, that is dy by dt upon dx by dt. So now putting the values of respective derivatives dy by dt and dx by dt in this formula. So our dy by dt is the second value, that is a cos t, and divide by dx by dt. Our dx by dt is a cos square t divided by sin t. So cos t will be cancelled, a will be cancelled, it becomes sin t divided by cos t. So it is tan t. So tan t is our answer. So this is the required derivative of the given function, and that is the main application of the differentiation of parametric equations.